All right, let's do another topic, which is a temperature unit conversion. This is a very interesting topic, and also this is very useful in chemistry. And I feel it's very challenging when I work with my kids. So I want to use this video to see how I can help to understand the temperature units and the conversion between them. Let's get started from what is temperature. So temperature is an intensive quality and describes the energy state of the matter. So what does that mean? If we can imagine like this, all matters have atoms and molecules that are in constant movement, just like here. They are constantly moving and vibrating and rotating. So it depends on the type of molecule or atom. There are no exception. So a different subject simplified, the more they move, the high temperature the material will have. So basically you compare these three, which one moves faster? Obviously this one moves faster, and then this one has the high temperature, and then this one moves slow, and this low temperature. Okay, so there is another type of description about temperature. The temperature of an object can be defined by the average kinetic energy of its atoms and molecules. So I'm sure we will have a lot of more insight when we learn physical chemistry about the gas, and this is going to have more complicated equations to establish the temperature and the kinetic energy relationship. So for simple, we just want to get this description as simple as possible. The temperature is used to describe the average kinetic energy of its atoms and molecules. Okay, so this is a very brief explanation about what is temperature. And what are the temperature units? So for me, I only familiar with actually only two, because I'm from a country using the SI unit. I'm familiar with this one because I learned chemistry, and I'm familiar with this one, Celsius degree and Kelvin. And when I come to this country, I was forced to use this F degree, which is Fahrenheit. So in the following videos, I'm going to give you a little bit more insight about these three units. I'm not very familiar with this and this, so therefore I'm going to skip that. But by the end of this video, I'm going to show you a very interesting question, which with that you can create your own temperature unit. Stay tuned. So let's first take a very close look at all this temperature unit. Start from the Celsius degree. Okay, so one thing we want to remember is for water, H2O, the freezing point or ice melting point, it is 0 degree. Okay, 0 degree. This is Celsius degree. This is one thing we need to memorize. So that's number one. Number two thing we need to memorize is the boiling point. Is the boiling point of water H2O again. Okay, H2O again. So it's 100 degree. This is the second thing we want to memorize this. Okay, so this is a little bit tricky. You will see the boiling point. The boiling point of water is always 100 Celsius degree. Yeah, that's probably not true. So at usually 1 atm, because the boiling point is closely related to the atmosphere pressure. If you define this is pure water, this is at 1 atm. The boiling point is 100 degree. Okay, so this is the this is two things you need to memorize related to Celsius degree. Okay, and then move to the Kelvin. The third thing you need to memorize is 0 degree is equivalent to 273.15 Kelvin. Okay, this is the third thing you need to memorize. Okay. The fourth thing is 0 degree. Is 0 Kelvin, sorry, not 0 degree, 0 Kelvin, 0 Kelvin. This is the absolute temperature, is absolute zero. What does that mean? Physically mean, did you remember? We see the temperature is the average of kinetic energy. So kinetic energy describes how molecules or atoms move, right? At 0 Kelvin, nothing move. Nothing move. It's frozen. It's absolutely frozen. Nothing move. So this is a very low temperature. If you convert it to the Celsius degree, that will be minus 273.15 Celsius degree. Okay. So and with this and this number and this number and this number, you can tell the fifth thing you need to memorize, 1 Celsius degree is 1 Kelvin degree. So the size, okay? The size, this is only the size. Please don't get confused, is 1 degree equal 1 Kelvin. So I only talk about the size or the change. Okay, let's use the change or the size. Okay, so this is a very important 5 things we need to memorize. Unfortunately, we need to memorize this. Okay, but another unfortunate thing is this is not the end of the knowledge point we need to memorize. The next one is related to the Fahrenheit. So this Fahrenheit, we need to memorize another two, which is the sixth one. This sixth one, for the frozen point of water, this is 32 F degree. Okay, so the seventh one is 212 F degree. This is the boiling water. This is the boiling water, which is equivalent to 100 Celsius degree. Wow. Okay, there are so many things we need to memorize. So, but it's very important for us to use those memorized knowledge to move forward to see how we can convert those things. Okay, let's move to the temperature conversion. I'm going to start from the most complicated one, from Celsius degree to Fahrenheit degree conversion, or the reverse way, right? So I will start from the Celsius to Fahrenheit conversion. So this is equation we can find online. I'm going to explain why it's look like this. How we get here. Okay. So we still use this. We still use this comparison. Two things I want to two alignment I want to have you do with me. One is the boiling, not the melting temperature of ice or freezing point of water, which is right here, 0 Celsius degree or 32 F degree. So this is one. Okay, this is 0. This is 32. Okay, the other is right here. The alignment right here. This is a boiling water at 1 atm, and then this is in Celsius degree, 100 Celsius degree, and then this is the boiling water at 1 atm. The boiling temperature of water at 1 atm in Fahrenheit, which is 212 degree. Okay, so this is those two alignment. Okay, so those two alignment. Once we have these two alignment, and then the next thing I want to ask all of us to do is to figure out the distance between these frozen temperature and boiling temperature. So if you do the math, you get 180 degree F degree, and then you do the same thing. You have 100 degree, okay, Celsius degree. Okay, so okay. Basically, right now I want to make this table with me for the change. So from freezing to boiling, you have the change of Celsius degree is 100. Okay, and then that's equivalent to the change of Fahrenheit is 180. Okay, so look at it. Those are the different, the scale of the change is different, but physically they are doing the same thing. Okay, with this we can do this type of math. The change over in Celsius degree over 100 equal the change in F over 180. Okay, so this is very, very important for us to understand how this factor come from. Okay, I'm going to do further next. Okay, so this is a very important milestone if you can understand this. Okay, let's see. We want to figure out what is the temperature right here. Any temperature. If you can convert to this F. Okay, so this is C. This is C. This is C or CX. Okay, this is CX. This is to convert to FX. Okay, so and then do the same thing. What we need to do is to figure out what is this delta C, the change of temperature in Celsius degree, which is you use CX minus 10. Okay, you can use this, or you can use this, doesn't matter, minus 0, sorry, Cx minus 0, basically you figure out what's the difference between the change from 0 to Cx. This is over 100, that equal the change from here to here, which is Fx minus 32 over 180. Okay, so how you're going to do? How you're going to simplify this? So let's do very quickly. So if you can, because you want to, one side you want to keep Fahrenheit Fx right here. Okay, so the goal is to move this to this side, and then move this also to this side. So basically, if you do the math right, you are going to have Cx Cs times 100 180 over 100 plus 32 equal Fx. Okay, so if you can simplify this, you get this is equivalent to this. Okay, so this one equivalent to this one equivalent to this, 32 is this. Okay, so this is how this equation we can find online come from. Okay, so I hope I make this clear. Not very simple, but I think if we can understand in this way, that will make you easy to memorize this. Or even you forgot, if you still understand and memorize the way we get here, and then you can find this equation by yourself. Okay. So let's move to the next slide, which is a summary of the temperature conversion. Okay, so this is I think this is a very useful table to have a summary for all the possible conversions. So the only thing we didn't cover is this conversion. Actually, in the previous slide, in the second slide, we already mentioned. So the size of 1 Celsius degree equal the size of 1 Kelvin. Okay, so they just have different offset. So the offset is Kelvin have a larger number. You just add 273.15. Okay, so if we know this, and then we know this, and then we know this, because this is pretty much equivalent, just reverse way conversion. Okay, so from this equation, this equation is what we described right here. Okay, so although this looks different, but if you can convert this as 9 over 5, that's equivalent to 1.8. That's C times this plus 32. That's equal F. That's exactly this equation, right? So, and then this one, and then this one is the reverse. So we can rewrite this very quickly. This one can move to this side, become F minus 32, and then equal C times 9 over 5, right? So this one can be moved to here by divide. So this is F minus 32 divided by 1.8 or 9 over 5 equal C. So that is this one. So this one and this one is a little bit complicated. That's because you have this offset. If you consider this offset, this one and this one is very similar to this one, and then this one is very similar to this one. Okay, so this one has a relationship, and then this one has a relationship. See, this is very complicated, but all right. So I hope you feel this is very interesting. And then let's move to the most interesting question. At least I feel in this way. Let's say you are not satisfied with both Celsius degree system or Fahrenheit degree system, right? You want to design your own temperature scale based on healthy alcohol, ethanol. On the Celsius degree, what we know is the melting point. Okay, so the melting point, just like the ice, okay, from the solid to liquid for alcohol, that is minus 117.3 Celsius degree. Okay, so this is Celsius degree. But for the boiling point, which is from the liquid to the gas, which is for water is 100 degree, right? So, but this is 78.5 degree, which makes sense. Makes sense because it is easier to be boiled than water. Does that make sense? Okay, let me pull out my calculator, try to calculate this. Okay, on the other side, what is your new temperature unit? You want to establish a E degree, okay? So this is your own unit, okay? So let's say what is this question describing? Your new scale is calibrated in unit of degrees ethanol, which is E degree. And then you can define this melting at 0, and then this is 200. This is 200 E degree. This is 0 degree. So very similar, right? So what I want to ask you to do is to align these and align these, right? So that's the first thing, align, okay? First, align. The second is find the difference. So it's very easy to find the difference. This is 200 degree, and I'm going to use my calculator to do this. I think 190 something. Let me do this very quickly. 78.5 minus this minus is plus 117.3. That's equal 195.8. Okay, so this is another number. So did you remember? So the difference. Find the difference. The third is relationship or ratio. Ratio. What is the ratio? The change of Celsius degree over 195.8 equal the change of E degree over 200. Okay, so this is very similar to what we described here, right? So very similar. So let's do further. And then let's see we do CX. Let's say we want to get any number along this Celsius degree, and then to try to convert to the E degree. Okay, try to convert to E degree. So EX. Okay, so what is this relationship? Okay, very simple. So you find what you need to do. You just do one more time. align. You already aligned, okay? You align, and then you will find delta C. What is delta C? Delta C is CX minus 117.3. That is plus 117.3, right? So this one divided by 195.8, okay? So that's equals what is the difference from here to here? That will be EX minus 0. And then that's divided by 200, right? So and then you can simplify this. You can easily to find EX equal and then 200 over 195.8 times CX plus 117.3. Okay, so this one is the conversion formula to convert a Celsius degree to E degree. Okay, this is your own temperature unit. It's cool, right? I'm not going to do this with you anymore, since I believe you can do it. If you can not do it, just let me know. Just leave your comment and I can send you the answer to see whether you can figure out yourself. Okay, so all right, at the end I would like to thank you very much for watching. And again, if you have questions or comments, please leave your questions or comments below. And if you like this, and please try to share with others. And if you want to follow up with my coming videos, please subscribe this channel. Again, thank you very much for watching.